Okay, this is Algebra 2, test number 6. We're picking up with part 2. Number 13 says, write the ordered pairs for the relations. I'll count them by ones, but notice all it's just showing the numbers that are 2. So this part right here, this point is at -2, +5. The next one, this one here, is at -1, +2. The next one here is at 0, 1. The next one here is at 1, 1, 2, pardon me. And the last one here is at 2, 5. Notice something about each of those ordered pairs. Okay, all of the y values are the same. The blue ones, the y values are the same. The red ones, the y values are the same. And then the vertex is down at the bottom. And that's what I mentioned that to you guys yesterday about having that line of symmetry. All you had to do for this one, though, is to list the ordered pairs. Those are the 5 ordered pairs. Then find the domain and range. The domain are all of your x values. -2, -1, 0, 1, and 2. So your domain, put yourself a little brace, is -2, -1, 0, 1, and 2. Okay? Your range are all of your y values. You do not have to list these numbers twice. So your range, you're only going to have 3 of them. You're only going to have 0, 1, and 5. 0, 2, and 5. That is your domain and your range. Hopefully I can make fewer mistakes on number 14. It says to graph this relation, then find the domain and range. Just graph each one of these. Notice none of these numbers, even though they have fractions that say 3/2, that's just 1.5. None of these numbers go past the number 2. So if you go 1, 2 in each direction, you'll have plenty enough space on your graph, and you can show the numbers that are the halfway points a whole lot easier. So for this first one, -1, 1/2. So your x is first. Remember, this is your x-axis. So you go to the left one, and then you go up 1/2. That's where the first point's going to be there. The next one, -1/2, -1. You're going to go -1/2 down to -1, so about right there. The next one, 3/2, which is the same thing as 1.5. 1.5, 0 will be 1.5, 0 would be there. And then the last one, 2, 3.5, or 3/2. 2, 3/2 is the same thing as, again, as 2, 1.5. So at 2 and at 1.5, there's the fourth point. So that's the first point. To graph the relation, it looks like that. Then find the domain and range. Again, same thing. Your domain and range, your domain are each of your x values. This one, this one, this one, and this one. So your domain, again, if it's listed properly, is -1, -1/2, 3/2, and 2. There's your domain. Your range are all of your y values. 1/2, -1, 0, and 3/2. Again, write them numerically increasing. So you have the smallest one is -1. The next smallest one is 0. The next smallest one is 1/2. And then the last smallest one, or the largest one, is 3/2. And there's your range. 15 says to make a mapping diagram of the relation. So put all of your x values in this one. Again, put them in numerical order. It makes it much simpler. They're already in that form. So -1, 0, 2, and 4. If you drew it as an oval, that's the same thing. You don't have to rewrite it. The same thing with your output values, 2, 0, 3, and -2. Again, put it in numerical order. So -2 would be first in that one, then 3, then 0, then 2, then 3. So those are your input and output values. Then show all of the relations. The relations are from -1, it's going to go to 2. So this one's going to go to this one. 0 is going to go to 0, straight across to that one. 2 is going to go to 3. This one's down here. And then 4 is going to go to -2. There's your mapping diagram for the relation. And we can tell based on what we have up there that this is a function, because there are no arrows leaving. There are no multiple arrows leaving the red side. 4f of x, that's how you read that. Remember, 4f of x equals 2x plus 7. Find f of -4. So all we're going to do is in place of x, we're going to plug in -4. So f of -4 is equal to 2x plus 7. If you have to, rewrite this part right here as y equals 2x plus 7, where you don't try to undo that f times negative 4. Some students do that. So 2x plus 7, but in place of, and I didn't sub it in on the second line, in place of this one, you're going to sub it in as the f value, which is negative 4. So times negative 4. 2 times negative 4 is negative 8, and negative 8 plus 7 is negative 1. So y is equal to that, or f of negative 4 is equal to negative 1. '17 was the one I told you to pay attention to, not because it's exceptionally difficult. It just kind of puts two problems together. It said, suppose f of x equals 4x minus 2 and g of x equals negative 2x plus 1. It says find f of 2 divided by g of 0. So let's focus just on this part for a second, and then we'll focus on the other part. F of 2 is equal to 4 times 2 minus 2. So 4 times 2 we know is 8, and 8 minus 2. F of 2 is 6. F of 2 is 6. The other one, g of 0, is equal to negative 2 times x, or 0 plus 1. Anything times 0 is 0 plus 1. So g of 0 is 1. So now this last part, after you have those two done, this last part says find f of 2, which we know is this, 6, divided by g of 0, which we know is this, 1. So when you find f of 2 over g of 0, 6 divided by 1 is simply 6, is the simplified version. '18 says graph this equation, y equals 3 over 2x plus 3. Do it the fast way that you know how to do it. Use mx plus b. This is b. It tells you where to begin on your y-axis at 1, 2, 3 is your first point there. Your m value tells you where to move. Tells you to move up 3 and to the right 2. So up 1, 2, 3, and to the right 1, 2. There's your second point. You have 2 points. You can connect the dots, and your graph should look similar to that. '19 tells you to find the slope. Use the 2 points that are highlighted. If you see 2 other points that look like they're easier, you can use them, but just by default, use the ones that are highlighted where you don't make a mistake. Notice these lines are counting by 2 each time, though. So remember, it's rise over run. How many times is it going to go up or down over how many times is it going to go left or right? We can clearly see you always start at the one on the left and you work to the one on the right. That way you'll have your negative number in the correct spot. Makes it a little bit easier. It goes down 1 time. Notice it goes down to the halfway point, and since it's counting by 2s, it's like going down 1. Down 1 means negative 1. It goes over 2, 4, 6, 8 times, and then it's in the half, so it goes 1 more, which is over 9 times. So there's your slope right there, negative 1 over 9. Again, don't let those halfway points fool you. It's counting by 2s. Number 20 says to evaluate y equals x plus 6 times x minus 3 when x is equal to 5. First thing you're going to do is sub in 5 in each of those spots. 5 plus 6 times 5 minus 3. 5 plus 6 we know is 11 times 5 minus 3 is 2, so y is 22. Three different properties. Name each of these properties. What's going on in the first one? On the left side, just separated from the left side to the right side. What does it look like on the left? What does it become on the right? It says negative 2 times instead of parentheses with x plus 10 in it. On the right, it says negative 2x plus minus 20. So what's happening is it is distributing to both of those. So that is the distributive property. Number 22 says pi times 13 is equal to 13 times pi. Again, it's exactly the same on the left as it is on the right, with the exception of the fact that the numbers move. They change positions. Things that move commute. Therefore, this is the commutative property. Negative 3.9 times 1 is equal to negative 3.9. It is negative 3.9 on the left. It is still negative 3.9 on the right. It multiplied by 1. Its identity remained unchanged. It was the same on both the left and the right. Therefore, this is the identity property. Remember, if it becomes 0, it's the property of 0. If its identity remains unchanged, identity property. Evaluate the expression for the given value of the variable. 3a plus 2b when a is 4 and b is negative 1. 3 times a is 4, so 3 times 4 plus 2 times b, b is negative 1. 3 times 4 is 12. 2 times negative 1 is minus 2. 12 minus 2 is 10. Negative 2 times x squared minus 5x minus 1 when x is negative 3. Again, in place of x. Negative 2 times negative 3 squared minus 5 times, again, negative 3 minus 1. Exponents first. Negative 3 squared is negative 3 times negative 3 is positive 9. It's still right next to negative 2. Then it says minus 5 times negative 3 minus 1. Do your multiplication next. This times this is negative 18. This times this, a negative times a negative, we know is a positive 15 minus 1. Those put together is negative 3 minus 1, and those together is, or those are negative 4. Number 26 says x to the third minus 2x squared minus 3x minus 1 when x is negative 2. Remember, it plugs in as if it's in parentheses. So negative 2 to the third minus 2 times negative 2 squared minus 3 times negative 2 minus 1. Exponents first. This to the third power means negative times negative times negative, which is going to be negative at the end. 2 times 2 is 4 times 2 is 8. So negative 8 there. Minus 2 times negative 2 squared is going to be positive 4. Minus 3 times negative 2 minus 1 multiplications next. You still have negative 8. Negative 2 times 4 is negative 8. Negative 3 times negative 2, and negative times a negative is a positive 6 minus 1. Negative 8 minus 8 is negative 16. Negative 16 plus 6 is negative 10. And negative 10 minus 1 is negative 11.